Hello, my name is Peter Shore, and I'm here today with my teammate Robert Montgomery, and we're going to be briefly going over our CUDA converter and Clang project for our compilers class. So, the first thing I'd like to go over with you all is the README file that we have written up. So, this file firstly gives a brief overview of what our project's built to do, to obviously convert explicit memory, unified memory to unified memory, and the other way around for CUDA applications. So, the next section that we have is going over how to set up the project, as well as how to set up and run the testing suite, and to convert code yourself running our converter manually. So the next thing we'll go over briefly is our actual CUDA converter. So we were able to implement our whole project in one C++ file using Clang and llvm. And so we implemented this using two front-end actions that run to either convert to explicit memory or convert to unified memory, depending on what the user is trying to do. Furthermore, we're using AST matchers to find critical statements in our converting code, such as CUDA malloc statements or CUDA malloc manage statements, and converting them appropriately so that the CUDA file is converted to the new memory type. So next I'll give you guys a brief example of how this actually operates. So to run our converter, you're first going to point to the application itself. So wherever you have your clang-llvm set up, you want to go to clang-llvm, build, bin, and then CUDA converter. The next parameter is going to be the actual test file that we're converting. So in this case, we have set up an example explicit memory CUDA file that we want to convert to shared. So the next parameter is either going to be to shared or to explicit, depending on what you're trying to convert to. The remaining parameters are mainly required, and except for the last one, which is going to be your output file. So for now, we're just going to output to a temporary file. So before we go ahead and run this converter, we're going to briefly show you all what this file looks like. So as you can see here, it's a pretty straightforward CUDA file. We have two CUDA malloc statements that are going to malloc to CUDA variables. We've got two CPU variables, and we just perform a couple CUDA operations on these. So say now that we want to actually use shared memories as opposed to explicit memory. So if we run this converter, it should output a new CUDA file. And as you can see here, the CUDA malloc statements have been updated to CUDA malloc managed. So now when we're actually running operations on these CUDA variables, we're using shared memory or unified memory as opposed to explicit memory. So now what if we want to actually add some optimizations to this as opposed to just running a base converter? Well, we can add up to two optimizations here, one being prefetched and the other being mem-advised. They can both be run at the same time as well, but you can either choose one or the other if you prefer. So if we run this real quick, we'll see what happens. So as you can see, we've now added the CUDA prefetch optimization, as well as added the CUDA mem-advised optimization on top of converting to unified memory. So the next thing we'd like to show you all is our testing suite, if you want to actually run just a set of tests, automated tests. So we wrote a quick bash script here that basically goes through and runs different example CUDA programs through our converter and checks their output. We've tried to do our best to test some edge cases on top of just normal conversion. So of course we have tests that just convert unified code to explicit and the other way around, as well as testing with different optimizations and combinations, as well as testing on files that might be a little bit odd, such as files that have both unified and explicit memory statements in it, seeing how we can convert a unified file like that, or converting a file that doesn't actually have any memory statements in it, to see how our applications would handle that. So to run our test, you just run the script. One thing to note is, by default, the testing script is set up so that it doesn't actually compile the CUDA output files to test the actual output. Like by default, it just compares the converted file to what we expect the converted file to look like. But if you actually have CUDA installed on your machine, you're on a CUDA capable machine, you can pass in true, and it'll actually run, it'll actually compile the output files and test that the output's the same as well. By default, actually, it is true, but you can also pass in false if you'd like to shut that down. As you can see here, all of our tests pass. And that summarizes our recording.